that is interesting. So imagine you traveled, okay, so imagine you are kind of moving on a double road, okay, so it's a 2-lane road, for example, okay, so it's a 2-lane road, so some traffic, so on this traffic, so the traffic is going, for example, to the left, and on this, so for example, the traffic is going to the, so to the right, and here to the left actually. And say you are in some city A and you are in some city. You want to reach to some city B actually. Okay? You want to reach some city B. Then, if for example I give you a graph of the velocity that goes like this actually. Okay, so some instant T1 and this is some instant T2. So between these two instants, the graph of the velocity goes like this actually. Okay. The graph of the velocity goes like this. So what would be the interpretation of the graph? First you are slowing down, then you are moving fast, then you're slowing down, and then you are moving fast up to the, what do you call, time. Now if I want to integrate, in other words, if I want to sum up all velocities, okay, sum up all velocities from the instant t1 to t2, what you're going to get? What you're going to get? I know that velocity is, okay, I know that the velocity is the change in displacement actually. So when you want to sum up all velocity from instant t1 to t2, you have to sum up all changes in displacement, okay, from the time t1 to t2. And what would be this? So this would be really s of t2 minus s of t1. In other words, the distance that you covered at up to the time t2 and subtract the distance that you covered up to the time t1. So in other words, this is the displacement actually between the instants t1 and t2. So when you compute the sum of all changes in displacement between these two instants, which is same as summing up all the velocities between of say for example your vehicle between the instant t1 and t2, this is going to give you the net change in displacement between these two instants. You can also think about it as acceleration. What if I sum up all accelerations from t2 to t1, instant t2 to t1 actually? Then, you know, by the same, I know that the acceleration is, okay, I know that the acceleration is really the change in the velocity, okay, so when I'm saying this, I'm basically saying that, okay, what is the sum of all tiny changes in the velocity between the instant t1 and t2? And when you're going to sum up all the tiny velocities between the instant t1 and t2, you're going to get the net change in the velocity. So t2 minus v of t1 actually. Okay, v of t2 minus v of t1. So I hope it is making a little bit of sense to you actually. It's making a little bit of sense to you that, you know, when you are writing a to b f of x dx, you can have two interpretations. So one interpretation is that, okay, it gives you the area under curve, okay, the typical one. But if you treat f as some physical quantity, then you can interpret this that I am summing up all, what do you call, I'm summing up all values of f from the instant a to the instant b actually. Okay? And this would be equal to, so if this is differentiable, in other words, if this has an antiderivative, then this would be equal to f prime of this dx. So in other words, you are summing up all changes in this capital F between instants A to B, and this would be equal to the net change in the antiderivative from the location A to the location B actually.